So now we're going to talk a little bit about adaptive immunity. The purpose of adaptive immunity is to build up a long-term, highly effective protection against a certain or multiple types of microorganisms. In order to produce this immunity, it requires the production of antibodies and antigens for protection. And these antibodies and antigens can be either actively or passively acquired. In active immunity or acquisition, it means that you have either been exposed to the microorganism or you have received immunization, which has provided you a controlled exposure to the microorganism. In passive immunity, you receive preformed antibodies from another source. And generally, when we're talking about passive immunity, we're talking about the kind of immunity that you get or that is passed from mother to baby through the fetal placental exposure. There are some key elements of adaptive immunity that you need to understand. There are two responses. One is humoral, meaning the immunoglobins are developed and that's the actual antibody responding to the antigens. Or there is a cellular response that involves both B cells and T cells. Now, the book gets quite intense about the different types of B cells and T cells, and I'm more interested that you understand what B cells do and what T cells do. So B cells are create the development of antibodies, and the T cell response is generally either trying to stimulate B cells to mature so that you can secrete more immunoglobins and get more protection, or it's targeting T cells that are called killer T cells that bind to the antigens and are trying to actively kill the invader the invader microorganism in the body. When you're talking about cellular response, you're talking about memory. There's memory in this process of adaptive immunity. There are different kinds of antibodies that are developed, and the antibodies and immunoglobins, that's this interchangeable word. We can test for these antibodies within the blood, and certain types tend to tell us what kind of invasion is going on within the body. So, for example, if you have a high level of IgE immunoglobins, then that is the immediate hypersensitivity reaction, or what we call allergic reaction. These antibodies are developed quickly within minutes and relate to the stimulation of mast cells. So there are high heparin and histamine responses as we talk about that inflammatory response. IgG is the biggest and the major antibacterial and antiviral antibody in the body. It is transferred across the placental connection, and you have large amounts of this type of antibody in your body. 80 to 85% of the plasma antibodies are IgG. IgM antibodies indicate that you have a beginning level immune response being mounted. We think of the IgM immunoglobulin as the first responder. It's a very large size cell, so it doesn't cross the cell membrane, and it is present mostly in the vascular system. So when we get high levels of IgM, we know that we have some sort of an immune response going on, and that it's in the very beginning stages. IgA immunoglobulin is, if we have a lot of IgA antibodies, it means that your epithelial response, your body surface response, including your respiratory tract and GI tract, those are considered epithelial responders and have a lot of IgA immunoglobulins. If this has been activated, if the system is activated, or if this immunoglobulin is activated, the body is trying to keep something out. It has not taken hold within the body yet. It is mainly a surface type response, and the IgA immunoglobulin is trying to keep the bacteria or virus out of the body. It's a very high level representation of how antibodies deal with the antigen. They can deal with it directly by neutralizing the actual virus. They can deal with it indirectly by creating a situation where the bacterium gets killed. They can release certain toxins and neutralize the toxins of the bacteria, or they can just eat up the bacterium with, through the macrophage process altogether. So these are just different ways that antibodies function. When we're talking about immune responses, we talk of it in two terms: a primary immune response and a secondary immune response. A primary immune response means this is the very first time that you are being exposed to the said invader, and it takes a while, sometimes up to 5 to 7 days, for that big IgM antibody to develop the antigen so that it can be detected. So there is a latent and lag phase in the primary immune response where the B cell produces the antibodies. It takes a while for that to happen. In secondary immune responses, the body is able to respond much quicker, and it produces larger amounts of the antibody to kill the invader faster. We can initiate this secondary immune response by providing booster shots for your development or for reactivating the immune response that you have. It was at one time we thought if we immunized people that this immunity, this shot gave them immunity for life. And what we have since found is that different kinds of vaccines or immunizations last different amounts of time in the body. So, for example, tetanus. You receive a tetanus shot to build up immunity so that you don't develop the disease of tetanus. And so we know that you need a booster shot every 10 years to keep those antibodies active and produced within your body, so that when you step on a nail or you scratch yourself against a fence post that has a nail sticking out, you don't run the risk of getting tetanus because it will mount the immune system. But if you haven't had a booster shot, When you go into the emergency room, the first thing they'll ask you is, when was your last booster shot? And if you say you can't remember, they will actually just give you one. Couple key ideas to keep in your mind with pediatric immunity. As the fetus has maternal antibodies that are provided for protection through the fetal circulation during the first few months of life. This is generally referred to as passive immunity, and creates a situation where, as the body is developing some sort of sensitivity to this new world that it's in, there is some fundamental basic immunity that the fetus has, that the newborn has, so that they don't just get sick and die from everything that they're exposed to. We do know that as you age, your immune system function declines. This is basically because you have decreased T cell activity, and that's because your thymus, as you grow old, begins to shrink up to 15% of its maximum size. When your thymus shrinks, it means that you have less hormone production, and that hormone production is directly related to T cell differentiation. So again, not only do you have less T cell activity, you actually have less T cells and less differentiation of those T cells as you grow older. And last but not least, we know that this whole antibody antigen response that is supposed to happen relatively quickly happens much more slowly as you age, because the systems are just older and more worn out. There's lots of detail in this chapter. Please just keep it simple and refer to my slides to keep you on track for your thinking, so that you don't stress out about all the